Alright, welcome. This is the last part of the Module 6 solutions for the review sheet. This is covering 10, 11, 12, and 13. Okay, so part 10. Four quadrants are shown below. For each of the following, identify which transformation would carry the identical figure using only one transformation. Make sure you check your answer on the approximate box. A is here, B is here, D is here, and C is there. Okay. Alright, again, you just have to rotate it for it to make sense. Alright, the first one, is it a translation? Yes, it is a translation because you're sliding to the right. Okay, you're sliding to the right. Give me a second here. I could pull it up side by side to give you a visual. Give me a second where I set up paint. Right, so look, it goes from A to B, right? It does slide, it goes sliding to the right. That is a translation. Okay, next one, we would say it's also reflection across x equals to 0, right? Because here, line, that is x equals to 0, flips right there. Right, that's the flipping, that's the reflection across x equals to 0. Does not reflect across y equals to 0. It's not also rotation. What about A to C? Okay, A to C goes from here to here. Okay, is it a translation? Yes, it does, because it slides down. It just goes down here, slides down, right? You see how the pointy end still points down? Good, right? Is it a reflection? No. If it's a reflection, look, if you want to see the reflection, let me show you to you. You want to see the reflection, it would look something like this. Okay. Reflect it like that. You see? That's not how it looks like. You see how it's still pointing down? It's not a reflection. Okay? Is it a reflection over the Y? No. Okay, because look, if you reflect it over the Y, it would look like, oh, does it reflect over the Y? Yeah, it does. It does look like it reflects over the Y. Okay. This is wrong. There should be a solution here. Okay, hold on. Okay, there should be a, this would be a check mark, okay? Because it does reflect across the, right, what was it? That does reflect across the, from A to C, I'm sorry. From A to C. Sorry, from A to B, it's a reflection. Not from A to C. So, sorry. So, that's right. So, A to C is not a reflection. It's only a translation. From A to D, sorry, from A to D, right? That's a 180-degree rotation. Let me show that to you. Here you go. Rotate that 90 degrees. Becomes this one. Rotate it again, 90 degrees. Boom. 90 plus 90 is 180. So that would be your 180-degree rotation. From B to D, we would say that is reflection across the y-axis. Watch this. From B, there you go. Watch me reflect it across the vertical. Boom. That's your D right there. Letter D right there. B. Good? That's why it is a reflection. Part 11. On the coordinate plane to the right, it undergoes a reflection over the line y equals to x. That green line here is y equals to x. To form triangle A prime, B prime, and C prime. Write the general rule for the transformation. Okay. Right, from A, I noticed A is here, B is here, and C is here. Always write the coordinate grid if you want to find the general rule, okay? And A double prime, A prime is here at -1, 1. B prime is 2, 3, and C is -4, 4. In this case, the general rule, it just flips. Notice the -1 just goes on this side, the 1 goes on to the right hand side. Same thing here. The 2 was on the right, it comes to the left. X was on the left, it goes to the right. Same thing here. So it flips flops. So we would say the general rule here is y is this becomes y comma x. That would be the general rule. Part 12. The coordinate plane shows the location of this quadrant A and quadrant B. Describe a transformation or a series of transformation that provides the quadrant B is congruent to quadrant A. Provide your mathematical justification. My first step here is to rotate 90 degrees counterclockwise above the origin, right? That is going counterclockwise, and that's 90 degrees. Then I reflect it, which is going to be the red one. That was reflection. Okay, so my two parts are a rotation of 90 degrees, then I have a reflection. You could do it any other way, right? Some students might have reflected, then rotated. Up to you. Okay, good. But again, right, this is across the equation y equals to 0, or you could say the x-axis. And part 13 is your last part. Describe the error in the solution. Here's the question. Determine the new coordinate of the image after the reflection. The solution. Apply reflection rule of negative x plus y. Oh, there should be a comma. How the z was positive, right? Because the student's justification is, notice how the z was positive, now the z is negative. Positive, negative. Okay? I did this for my justification. Now I'm going to describe it, okay? The reflection rule is wrong because, yes, z does become from a positive to a negative, but s and q does not do that. S prime and q prime does not have negative values. Look, it was starting at a 2 for s. S prime does not become a negative. Q was a 2, does not become a negative. Okay, the student here says this line of this reflection rule, this should be a comma. Is true? No, it's not. The line of reflection here is x equals to 1. It goes up, down, straight vertically. That is why it's x equals to 1. Okay, that is why the student is wrong. This is an error analysis problem. Okay, so there you go. That is your solution for part 3 of the review.